Hi guys, today we're talking about normal distributions, which is a very special kind of a density curve. Chances are you've seen what they look like. They look like bell-shaped graphs. They're symmetric, they're single-peaked. The two values or parameters that define them are the mean, which is this Greek letter mu on your screen, and the standard deviation, this Greek letter sigma. Okay, so any normal distribution has a center at its mean. Mean is equal median because they're symmetric, and that's the letter mu. And the standard deviation kind of decides how spread out the graph is, right? Some are narrower and taller, and some are wider, right, and shorter. So it depends, but remember, 100% of the data is under the curve. That's a property of a density curve. So these are just some special things about normal distributions, right? It's a normal density curve defined by mean and standard deviation. Those are the two, we call them parameters that you need to know everything you need to know about normal distribution, right? The standard deviation is the distance from the center to that change of curvature inflection point on the graph, and that's what standard deviation is. So there is a clear rule, it's called empirical rule for normal curves. So 68% of the data, is within one standard deviation of the mean. So it has to be within, so it's plus one standard deviation minus one standard deviation. That's 68% of the data. Remember, 100% is under the curve. 68% of it is one standard deviation is away from the mean. Now, two standard deviations away from the mean, that's your 95%. Right? And lastly, you have your three standard deviations within the mean. And it's almost 100%. It's 99.7%. Okay, so that's the, it's called empirical rule. 68, 95, 99.7. And that works for any normal curve, regardless of what the mean and the standard deviations are. Okay, so we're going to keep going here. So here's an example, right? It says the distribution of Iowa test of basic skills, vocabulary scores for 7th graders in Gary, Indiana is close to normal. And they give you this distribution. N means it's normally, approximately normally distributed. The mean is 6.84. The standard deviation is 1.55. So to sketch it, you would put the mean down at 6.84. And then you count up by the standard deviation, so you add 1.55 each time. And here you would subtract by 1.55 each time, and that's how you make the graph. What percent of ITBS vocabulary scores are less than 3.74? So 3.74 is right here, and we're looking for less than, so this is the green area. So remember, the red here is within two standard deviations of the mean, and that's 95% of the data. And that leaves 5% on the ends. There's an end on the right and an end on the left, right? So we have to take that 5% divided by 2, and it's about 2.5%. Okay? And lastly, the question is, what percent of the scores are between 5.29 and 9.94? So you could see 5.29 right here, 9.94. So we're looking for this combined shaded area, right? The red part is about 68% of the scores. This green part, to get this green shaded part, you have to take 95%, which would be all of this, right? And subtract 68 from it. And then you have to divide it by 2, because you don't have it shaded on both sides, only on one side. So the correct answer would be 13.5% plus 68%. So we'll keep going. Now you can standardize a normal curve. Any normal curve can be standardized. By standardize, I mean you take a normal curve with a certain mean and standard deviation, and you transform the data, standardize the data, and make it into a normal curve with a mean 0 and standard deviation of 1. Now, that's Easy for computation purposes, easy for graph purposes, because you're just counting by one. Standard deviation is 1, and the mean is 0. So it goes 0 in the middle, 1, 2, 3, -1, -2, -3. Now, there is a table you can use to find values. I prefer using a calculator. We do have that table under the Formulas and Tables tab on Content Library in OneNote, so you're welcome to use it. But suppose you wanted to find the area under the curve, like the proportion of values from the standard distribution that are less than 0.81. So this would be the notation for it. Probability that the z-score is less than 0.81 is equal to, right? And from the table, you'd find the z-score of 0.8 and go over to 0.1 because 0.81 is right here. And the answer would be 0.7910. So it's about 79%. It asked what proportion, so we'll leave it as 0.7910. 4 decimal places is typically what we would do for proportions. Now, on the graph, if you look, 0.81 is slightly less than 1 standard deviation above the mean. You shade everything below it, right? And it makes sense that it's about 79% of the data because, remember, under the curve is 100%. Now, I prefer using a calculator. This is how we would do this on a calculator. We would do second distribution. We would choose number 2, normal CDF. And here, because we're not starting at -3, remember, it kind of goes to infinity over there, right? So what I do, you can put in a really big negative number, just put in a bunch of 9s. I prefer using my scientific notation and putting this down, just because that goes as far as possible. But putting -999999999, fit a bunch of 9s in there, that's okay too. Okay, for the upper, we're going to put in 0.81 because that's our upper limit, right? Our lower limit here is negative infinity. Our upper limit here, or upper bound, I guess, is 0.81. And the mean is 0 because it's standardized, standard deviation 1. And then we press enter on paste, and then we press enter again, and there's our answer, and we didn't have to use any tables, okay? The issue with tables, really, is that they only show probability below a z-score. So to find the probability above the z-score, you have to remember to do 1 minus. To find between, you have to do some extra work. Calculator just seems to be an easier option here. So here it says finding areas on the standard normal curve, and it wants us to find the area between a z-score of -1.25, right, and 0.81. So we would do the same thing. We would do second distribution, and again, normal CDF, because we're working with a normal density curve. And now the lower bound, right, is -1.25. And the upper bound is 0.81, right? And we're looking to see the proportion that's shaded here. So I'm going to say paste. And there is my answer, 0.6854. Now, when we're working with word problems, we like to follow this format: state, plan, do, conclude. Okay? Now, we always say it's a 5-step process, not a 4-step process. So state, plan, do, conclude, that's how you do statistics, dude. But we have to add step number 5, and that's making sure that we do a graph or a picture and shade it as needed when we're talking about normal distributions. So on your skinny, it'll say a 5-step example. That's what we mean by 5-step example, is that you have to do state, plan, do, conclude, and make sure you include a graph as well. So here's an example. It's a Tiger Woods problem. It says, when Tiger Woods hits his driver, the distance the ball travels can be described by normal distribution with a mean 304, standard deviation of 8. What percent of Tiger's drives travel between 305 and 325 yards? So first thing we would do is standardize these values, right? We're looking for between. So if you're using a table, you'd be looking at both z-scores and you would be subtracting them. But because we can use a calculator, we will do second distribution, right? And we're going to choose number 2. Now remember, the way we figure out z-scores is by following the formula. The value that we have, right, minus the mean, which is 304, divided by standard deviation. And that's how we got this value, right? So the lower bound here for z-scores is 0.13, right? The upper bound is 2.63. And because they are standardized, the mean is 0 and the standard deviation is 1. And then we can say paste and press enter, enter. And there's our answer, about 44%, about 44%. So again, state plan do conclude the part that state would state that we are looking for percentage of tiger's drives that travel between 305 and 325 yards given a normal distribution with a mean of 304 and standard deviation of 8, right? Plan would include the pictures, doing would be all these computations, right? And then for conclusion, we would say about 44% of tiger's drives travel between those two amounts. So we're going to keep going here. Now, how do we assess if we have a normally distributed data? So first you need to make sure you have all your data values. You're going to graph them. You're going to do a dot plot, stem plot, or a histogram. You're going to be looking to make sure it's approximately symmetric and bell-shaped. That's not enough, though. You also have to check whether it follows that empirical rule. So you have to calculate your mean and your standard deviation. And you have to see how many of your values fit within one standard deviation from the mean. If it's about 68%, great, then you will check within 2 standard deviations of the mean. And if that's about 95% of your data, then you'll check within 3 standard deviations of the mean. That should be almost all of your data, 99.7. It should be close. It doesn't have to be exactly 99.7, exactly 68, or exactly 95, but it needs to be pretty close. Another way to assess normality is through normal probability plots. We'll talk about those a little more in class. They are accessible to you on your calculator, and we'll talk about how to make them. But it's basically a graph where you do z-scores against the percentiles. And what you are looking for, if it's a normal, if its data follows a normal distribution or approximately normal distribution, is you're looking for a straight line on a normal probability plot. This line curves. It's not really a line, right? Because the data, when you look at the histogram, you could already tell it's not going to be approximately normal because while it is single peaked, it's not symmetric. It's definitely skewed to the right. It's a right skewed histogram, right? So that's why you see this right here telling you this data is not approximately normally distributed. If it was, it would follow in a somewhat of a straight line or very close to a straight line. That is it for today, guys. I will see you in class tomorrow.